We're live. Well, this is kind of an honor, getting to kick off Engineering Week. I feel highly underqualified, but I'm in a room full of some great engineers here. You guys in Quincy, I guess you can hear me all right. So I was invited to talk a little bit today about, oh, you all know me, I'm Tim Anderson, radio product line and new product development. A lot of time spent with digital radio formats around the world, HD radio, DRM, DAB. So they asked me today to come in and talk a little bit about DAB. It's probably the one I know the least about, so this has been quite an education. What I found out is it's pretty much the same as all the other digital radio formats out there, with a few variations. It's certainly one of the most prolific in the world right now, and doing very well. It's very mature. So let's get started. We're going to talk a little bit first about the history, how the DAB got started, where it's going. We'll get into the global situation, who's adopted, who's adopting, sort of the global leaders. We'll talk a little bit about the technology, sort of a high-level view, the pieces and parts that go into it, and how it all goes together. And then we'll talk about our play, GatesAir's play in DAB around the world. We're certainly the leader in DAB for most of the broadcasters around the world. So, a little brief history of the world according to DAB. It was the first standard digital broadcast system that was based on OFDM. It's been around for quite a while. It's become one of the most popular transmission schemes and is used around the world. All of the digital broadcast systems are based on OFDM. The project started in 1980 as a collaboration between IRT, as well as ARD, ZDF, ORF, broadcasters in Germany, and SRG, SSR, as well as France Telecom and our friends over at TDF. So it's had a pretty long history from the original development. In 1985, the MPEG-1 audio layer 2, or what's called MP2 codec, was created as part of this project. It was called a project called EU-147. First demonstrations of it were done at the World Administrative Radio Conference and Orbital Conference in Geneva, Switzerland in 1985. So it kind of grew out of that. It became the Eureka project, 147, and that's how it got the name Eureka. The original DAB format was called Eureka 147, and that was established with funding out of the European Commission. Originally, EU-147 was kind of looked at, there was some thoughts towards broadcast, but it was more of a digital format for satellite broadcast. It's how it was originally looked at. That's why it came up at the WARC ORB. But they quickly realized this was a viable vehicle for digital radio broadcasting. So Eureka 147 was started. The first DAB transmissions were tested in Germany as demonstrations. Then development went on. By 1993, the DAB protocols were kind of finalized. They were adopted by the ITU in 94, and then 97, ETSI also adopted formal standards. So that was really the beginning of DAB, with the first commercial broadcasts being launched shortly thereafter in 95. Several European countries, Germany, France, the UK, began some of their first commercial DAB broadcasts. Standards were originally coordinated by the European DAB Forum back in 95. That was sort of reconstituted as the World DAB Forum in 97, and 30 countries signed on to that and participated in those forums in the development of DAB. In 2005, the World DMB Forum had the technical committee, had their technical committee start working on what needed to be done for a new codec, a more efficient codec that was coming on the scene. AAC Plus had better error correction, better coding, more capacity, and that led to the launch of what's now called DAB Plus in 2007. In 2006, World DAB Forum became the World DMB Forum, and that's now the overriding body for the DAB and DMB standards. DMB, we'll talk about it in a minute, but DMB is a video adaptation of the DMB form, DAB format. Can be used to transmit video as well as audio programming. So what grew out of that Eureka family of standards? DAB in 1995, again with that original MP2 codec with PAD data services, program associated data. You could transmit text and limited other data along with the programming. TDMB was developed again to add video transmission services by adding an H.264 codec to the mix, still within the same transmission standard, just different codecs to be able to handle video. And then in 2007, they rolled out the AAC Plus codec, which became the DAB Plus. So why DAB Plus? Well, it gave them 2.5 times more capacity by using this new high efficiency AAC Plus V2 codec. Gave slightly better coverage because of better forward error correction coding than DAB had previously. More flexibility with the program associated data, more data was able to be transmitted, and more error protection for that program associated data. So DAB Plus, both standards are still used for audio broadcasting. They're not backward compatible with one another, so countries that adopted later on in the program tended to go with DAB Plus, while some of the earlier adopters are still using DAB. The receiver chipsets out there can do DAB Plus and DAB, so countries are in pretty good positions with both formats, and they're both still used currently. But DAB Plus is certainly the favored standard. Again, there's really no difference in the transmission protocol, just different coding, different error correction, and certainly higher capacity in the DAB Plus. DAB can handle up to 10 radio and data channels. DAB up to 10. DAB Plus up to 24 broadcast radio and data channels. And then, of course, DMB, 7 videos with some radio and some data channels as well. You get about 1.152 megabits at a half FEC coding rate out of the DAB Plus. Very flexible in how you set up the rates and the power trade-offs, anywhere from 576 kilobits to 1.728 kilobits for the full channel. Each transmitter can operate DAB, DAB Plus, and DMB without any changes. So it's the same physical transmitter, no difference in the transmission hardware, just a difference in the coding hardware and software that's feeding that transmitter. And those differences are in the audio coding, the video coding, how the data server is set up, and the error protection that's used. There are multiple audio, radio, digital transmission standards around the world today. The first was DAB. Later on came DAB Plus. HD radio has been around. We've all heard of HD radio, I hope. I'm not so sure sometimes. DRM and a new one, CDR, that we're heavily involved in, China Digital Radio. The DRM, HD radio, and CDR are considered IBOC, in-band on-channel services, whereas DAB, DAB Plus are dedicated channels, strictly for the digital service, whereas the IBOC channels can transmit simultaneous, plus a little more or less simultaneous analog and digital information. IBOC came along pretty much through DRM and HD radio because of the need in some countries to continue. They didn't have the available spectrum to move to all new services, all new digital services. We needed to preserve our analog FM along with introducing the digital services, and that was really the case in the US, where HD radio came along and some of its predecessors and folks that were working on bringing digital radio to the US, we had a problem. We didn't have the spectrum available to start all new digital services, plus we had all these radios out there, and many countries fell into that same boat. So you've had two different substandards of digital radio being developed over the last 25 years. One to support all new services, all new digital, and then for countries that needed to preserve their legacy FM services along with new digital services, this in-band on-channel was developed. So there came DRM, HD radio, and now China Digital. And as we look at these, the reason that they, the way they were developed and the reason they were developed were under different circumstances. Again, in the United States, we needed something, and other places around the world, we needed something to coexist with existing analog FM broadcast. DAB was a whole new boat. It operates typically in band 3 or in L band. Most countries operate it in band 3, which is the basically abandoned TV channels. So somebody help me out here. What are they? They're 174 to 240 megahertz. That channels 3 through 7. 7 and up. Okay. So they work in those abandoned television channels. For countries who were going digital TV, those channels became available, and so it was a natural place to put it in those countries. And then L-band 1452 to 1479 and a half. No difference really in the, again, in the coding or in the codecs, but just different transmission standards. It does permit for some simulcast of analog by steering to an existing analog FM channel. So I do say yes when it allows analog simulcast, but it's not really designed for that, but they can support some limited analog simulcast. It takes 1.5 megahertz of channel bandwidth and gives you a capacity of 1.5 megabits per second. They use 1536 OFDM or QPSK carriers in the OFDM signal. You compare that to HD radio, DRM Plus, and China Digital, which are kind of similar in that what we call the hybrid or IBOC system. Typically, these are 1 to 4 digital audio channels. Again, depending on the bandwidth, they're flexibly programmed. They can do simultaneous analog and digital within the same channel. HD radio specifically, I mean, we all know HD radio has got the 2 side bands and the analog right in the middle. If you've got an existing FM receiver, you get analog FM, but if you have a digital receiver, it'll transition to the digital signals. DRM, not quite so simple. It actually has to, again, steer either to an adjacent analog channel. They don't sandwich the analog inside the channel, so it's not really in-band on-channel, it's an in-band adjacent channel. And then China Digital, very similar to IBOC. China Digital is they came along later. They were able to take kind of the best of DRM, HD radio, and DAB+. Very flexible, almost too flexible. There's, I think Ted Staros figured there's like 11,000 possible combinations of bandwidths and codings and different configurations for China Digital. But it's a very flexible system, and they're pretty excited about it. The first rollouts of China Digital happened Just this past year, we installed 4 GatesAir transmitters doing the first China digital broadcast services. There's no receivers, mind you, but they're on the air, chicken or the egg, I suppose. When we look at DAB and DAB+, in circumstances where it makes sense to have multiple broadcasters all going into a multiplex and all going through the same transmitter, under those circumstances, DAB+ makes more sense than pretty much any other format. When you look at the equipment involved, the cost involved, in this typical example, I said 24 radio programs, but if you took 18 radio programs, say for FM only, you'd need 18 transmitters, 18 frequencies, 18 licenses, 18 studio transmitter links, 18 RDS encoders, 18 antennas, maybe. So it's a lot of equipment, a lot of cost. With IBOC, you can have either China Digital or DRM or HD Radio. You can have up to 4 program channels into a single transmitter. So again, to get those same 18 broadcasts, you need 5 transmitters and 5 frequencies. So it gets better. It's an improvement on equipment utilization. But with DAB+, you can get up to 24 program channels. In this example, 18 programs. That's 1 transmitter, 1 frequency, 1 license, 1 of everything, as opposed to needing all that additional hardware. It's a much more efficient use of systems and equipment. Not only that, it's a much more efficient use of power. Power consumption for FM, to do that, again, that same 18 radio stations, you need 200, typically, 13, 14 kilowatts per station. You need 250 kilowatts of power, and at 15 cents per kilowatt hour, that's $328,500 a year to operate those 18 stations. When we look at IBOC, of course, the cost goes down. You only need a total power of 22.5 kilowatts to get the same coverage for an annual energy cost of about $30,000. So much more efficient there, but DAB wins the efficiency prize. Again, if it works for the given situation, you're only talking about 6.25 kilowatts of power used for those same 18 stations at about $8,000 cost of power annually. So much more efficient in terms of power consumption. The problem, of course, with DAB is, one of the other problems is getting everybody together, being willing to share the same multiplex. Every station gets its slice of the pie, but in the US, we're kind of proud of our 100,000 kilowatt grandfathered CPBE stations, and broadcasters weren't so willing to share alike, because everybody in DAB, everybody gets the same slice of the pie. No one is better than the other. No one gets better coverage than the other. And so that's kind of an issue as well. But in countries where it works, where the broadcasters are homogenized, so you've got the BBC basically providing broadcasts for the entire country, or in Australia, you've got government broadcasts where everybody can be the same, it makes a lot of sense. And that's what has really driven DAB adoption. Around the world right now, over 500 million people are receiving a DAB signal every day, and can receive it. They're within range of a DAB signal. There's over 1,000 services that are on the air already. I've had some huge successes in some countries. Australia did it very, very well. Belgium did it well, Germany, Hong Kong, Netherlands. Norway, one of our huge success stories. Norway is putting on some 600 DAB transmitters across the country, and we're a big, big part of that. And they've, well, we'll get into that in a minute, but they've already announced their total transition to digital. Other countries like South Korea and Switzerland have done well. Canada was a huge failure, again, because broadcasters in Canada are more independent. They didn't get a real good rollout of receivers. There wasn't a national push to go digital. In fact, Canada is actually looking again at HD radio as a real possibility. We're talking to the CBC now about doing some more demonstrations, some more trials of HD radio throughout Canada. One interesting one was what failed and then what succeeded. The UK was one of the first countries to really push and really try to adopt DAB. Being an early adopter was part of the problem. They were early on. It was DAB. They underestimated the amount of power. Boy, that sounds familiar with HD radio. They underestimated the amount of power they needed for building penetration and like coverage for existing FM. So it was a very disappointing rollout initially in the UK. However, they've revisited the subject. They've increased power. They've increased their marketing efforts. They've increased the rollout of receivers, and they're on the verge now of right now of rebuilding their system, and it's looking like it's going to be very successful. So they are in our success category. Some of the world leaders right now. Switzerland, 123 stations on. They've got 99% of the country covered with DAB broadcasts. Receiver penetration's still lagging a little bit. 43% of the receivers out there can do DAB. But the interesting thing about Switzerland, 49% already of the radio listening is done either DAB or the internet. So they're already very in tune to digital broadcasting, whether it be over-air broadcast or internet broadcast. 60% of their cars today are equipped with digital radios, and they're working on their infrastructure to bring DAB into the tunnels and buildings where it doesn't penetrate to improve the coverage. Again, I mentioned UK, and they're now one of the success stories because 30 million people are listening to it. 80% of their cars now have DAB receivers in them, and they're doing this new nationwide multiplex rollout, bringing a lot of new services, a lot of new stations online right now as we speak. This next year will be a big test in the UK, but they've already got 96% coverage of DAB broadcasts, and 54% of the country now has access to digital radio receivers. 283 stations currently on air, and that number is expected to double. Norway, one of the great success stories. 99% of the population is covered. They've got 60% receiver penetration, and they've announced a digital analog sunset date where they're going to turn off their analog FM in 2017, and that's the first real announcement of FM turnoff by any country, and they're planning to stick to it. They figure that they've got 60% penetration, and more than half of the listening done today is via digital radio. Denmark's another interesting one. They launched in 2002. It's a small country. They've got 23 stations broadcasting in DAB Plus right now. They've got 98% coverage of the country with those 23 stations, and 46% penetration of the listeners out there can receive the digital broadcasts. So what they've done is they've made an announcement. The Communications Ministry has issued a new roadmap for their digital rollout, including criteria for the switchover, which is going to occur somewhere between 2020 and 2027. They've got some criteria placed on that. We'll talk about that a little more in a second, but it's rapidly growing there. They're doing very, very well with it. The DR has increased its listening figures. That's the broadcaster, primary broadcaster in Denmark, has really increased their listenership on digital radio. One of the issues that they're having there, I was just over there last year talking to them about it, they've got a lot of very old FM infrastructure. Their analog FM is very old. Most of these are 20, 30-year-old tube-type transmitters. They typically run 5 and 10 kilowatts FM, and because they thought that the digital rollout was going to happen much faster than it did, which has been the case in a lot of the countries, they're suddenly realizing that these 20 and 30-year-old tube-type FM transmitters are going to have to be replaced. They're not going to hang on till 2020, 2017, when they think they can get to this rollout. So we're seeing renewed activity in Denmark in replacing one more time. That's the way they're looking at it. One last time to replace their analog FM transmitters. So that's kind of interesting. It's a lot to read here, but the latest news from around the world, this is the latest as of last week. Of course, Norway has announced their digital switch off, digital sunset for turning off their analogs in 2017. Switzerland has announced plans, at least, of their roadmap between 2020 and 2024 to turn off their analog FM. Germany has been working on their digital infrastructure to drive digital adoption. There's more receivers, more digital receivers going into automobiles. As I mentioned, the UK's launched a major program to build out new multiplexes for DAB and DAB Plus coverage. They've licensed a second national commercial multiplex, and 18 new stations are on the air now, or going on the air, as we speak. Denmark, I mentioned, has got a roadmap. When they hit 50% of their listenership, they're going to go ahead and announce a sunset date. So that may be coming along fairly soon. They're getting very close to that 50% penetration. Let's see, Netherlands is coming along. New rollouts and new regional services are starting. Italy has got work going on with AGCOM, and they're going to push forward with DAB. They're trying to get 43% total population coverage. France has been on the air in Nice for quite some time. Last December, they proposed a new timetable for deployment of more multiplexes across the country. Belgium's doing well. Austria is doing well. Poland has put in new services as well. Romania, Slovakia, Slovenia, Asian Pacific, and Australia are doing very, very well, by the way. New multiplexes have been awarded, and new stations are going on the air all the time. They're looking for penetration to rise another 23%. Let's see. South Africa is doing trials and has already got quite a bit of the country covered. Turkey is very interested, and they've started some broadcasts in Ankara with 5 simulcast multicast stations. I mentioned before that it might not be efficient in every country, in every situation, and even in countries that have adopted DAB all out, it may not be effective for the small broadcasters to join one of these multiplexes and be one of 24 in a single multiplex. It works great when you can fill up that multiplex, but what about stations that are independent, where it's 1 or 2, 3 stations? There's some interesting things going on there, and we've tinkered with this a bit. There's a way to do DAB Plus on a much smaller scale, where you don't roll out a nationwide network. Maybe you've just got a couple of stations doing DAB for a fairly modest investment. For a full-blown head-end DAB system, we're looking at 30,000, 50,000 euro to get one of these systems up and running. And we can do the equivalent coverage with a single FM transmitter at about 1 kilowatt. So there's this new thing called open source DAB. It's the opendigitalradio.org has made available open source head-in software that can run on a PC, that can work with virtually any transmitter in band 3 or L band. So with a PC, a little know-how, USB, and maybe $5,000 investment, you can put a 2 or 3 channel DAB system on the air. And you got to be a little bit of a mad scientist because there's no documentation, there's no manuals. This is science fair project stuff, but it may evolve into something. And we've been looking at it here as a possibility to support small independent broadcasters who want to roll out a very limited DAB system. Digris is doing it in Switzerland. In the UK, Ofcom is working with it, and they're also working with it in France and Norway. Very small, limited systems. All you need is PC and a little Linux know-how, and you too can be a broadcaster. Like I say, bit of a science experiment. There's a couple of, this is one in Zurich on the left, on your right. One in Zurich, definitely a science fair project. And then a little higher class over in Lake Geneva, Switzerland. There's actually a VAX compact on air broadcasting this open service. So watch this. This is going to be kind of interesting to see what happens. I think there's going to be more development around this. opendigitalradio.com, facebook.com, Open Digital Radio if you want to learn a little more about it. So let's talk about the system a little bit, how it works and what the parts are. So the features that DAB brings, I mentioned 24 audio program services, this high efficiency AAC codec, very flexible in terms of sample rates, whether it be mono, stereo, parametric stereo, quasi-stereo, dual channel, being able to transmit this program-associated data, text, and information that goes along with the program content. They've also got the capability of doing MPEG surround sound. 5.1 surround is available in DAB+. There's also data applications that are very, very well developed and are also being adopted for DRM and HD radio as well. And I'm sure China Digital will be developing some of these similar data applications. But it does support what's called dynamic labeling. It supports a thing called Journal Line, which is a magazine type of a text service, hierarchical. You can drill down through and find information through the Journal Line service. The Mott slideshow, that's their version of slideshow, being able to put graphics, album art, limited video, that kind of thing, and have it display on the radio screen. Very well developed there. They were one of the first ones to really put work behind video over the radio. Broadcast websites, being able to view websites and page through websites on your radio receiver. Electronic program guide, where you can go through and select the programs that you want. You can even set up schedules. And instead of having to remember, 98.7, the channel number, you can just go to the program. You want to listen to a particular program, you just touch it on the screen and not having to remember channel numbers, that kind of thing. File casting, being able to do file transfers to the radio, either for updates or for data consumption. TMC and TPEG traffic, two different traffic systems. One is a message channel, the highway is blocked at exit 47, that kind of messaging, and TPEG traffic information that can do graphical maps and actually chart traffic flows. They have weather services, again, album art, a lot of data services are available on DAB and DAB+. Oops. So, talk about how it goes together a little bit. It's based around the ensemble structure. which allows multiple different radio stations to transmit on the same frequency, multiple different radio stations to use the same transmitter or different transmitters, because this is very well suited to single frequency networking as well. All of the right hooks are in the system to do single frequency networking, and multiple radio stations can then share the cost of these transmission systems. So it's really flexible, and it lets them deliver the content much more efficiently than single channel broadcast. Signal processing starts with the intake of the program or data content. It's digitized, it's rate reduced, the data is brought in, formatted and adapted. It's then sent to a multiplexing system where the multiplex is put into subchannels, and the error protection is laid on each of those subchannels for a final data stream that's then sent from the broadcaster or multiple broadcasters to the Ensemble system. So this is basically the front end, the encoding portion of it. And that may be at the station level or at the network level. And then it starts to get a little more complicated. What we were talking about was the program and data providers bringing into the service, what's called the service component provider. That's where the encoding is done. From there, these streams, and those could be at individual stations or individual networks, programs 1 through N are multiplexed together, sent down to the Ensemble service provider over something called STI, Service Transport Interface. They're sent to the Ensemble service provider, which may be located in another building, another city, or it could be right there in the network facility. That's sent over the STI protocol to the Ensemble provider, where all of those different networks, all those stations are brought together into the Ensemble. Again, that's done over the Service Transport Interface, which is then all assembled, error protections laid on, all the encoding is done, and then that's sent out to the transmission network provider, basically the broadcast transmission system, the transmitters. In Europe, many of these are broadcast service providers, where the stations don't own the transmitter, they don't own the tower. They just get a data feed that's sent into the transmission network system over a protocol called ETI, which is the Ensemble Transport Interface. Both the STI and the ETI were originally intended to be transported over TDM networks, like E1, fractional E1 services. But today, of course, the trend is sending everything over IP. So some work was done a few years back to encapsulate both those STI streams and the ETI streams into the EDI stream, which is becoming very popular now, the encapsulation of DAB interface. The EDI stream was developed to encapsulate both of those STI and EDI streams into an IP wrapper, or a wrapper that could go into the IP, better way to put it, so it could be transmitted over IP networks using the DCP, or Distribution Communications Protocol, standard internet, standard IP transmission. There's been quite a bit of work done on that recently. So now the network looks a little more like this. The STI is provided as an EDI over IP to the cloud. This lets the cloud distribute to the Ensemble, to the broadcast system, Ensemble controller. It can be routed, it can be switched, just like any other IP. And then out of the Ensemble controller, the EDI over IP, again, this time it's now the ETI stream wrapped in the EDI wrapper, so it can be sent over IP, again, out to the cloud if necessary, and then to the transmission systems. So we've done quite a bit of work on that here. Those of you who've been involved in it, that's kind of how it all fits together. This just allows us to send the DAB signals over IP. In the ensemble structure itself, it's a pretty flexible system that allows them to carry multiple services and multiple networks. So you could have one network doing 2 stations at 128 kilobits. You could have a second network doing 4 stations at 256. Third network, 3 stations at 192 kilobits, and maybe another network doing 9 total stations for 576 kilobits. And all of those bandwidths are dedicated to those network services. So you got a total of 18 stations taking up pretty much the whole bandwidth of 1152 kilobits. There's a little bit left over. What this means is each network can have their own capacity. None of the other networks have access to that capacity, so that's all theirs. They can be reconfigured on the fly. Different station with network 1 with 2 stations could decide reduce their bandwidth, put 3 stations on. What this allows is something called pop-up services. So broadcasters can decide this week they want to do an all Elvis channel and pop up all Elvis in there. It takes a little bandwidth, put up all Elvis for a week, and then take it down. It's kind of an interesting ability to reconfigure, but networks 2, 3, and 4 aren't affected by this. They get to keep, they have their original bandwidth. The audio encoding is, again, very flexible. You can vary the sample rates. You can decide whether it's going to be stereo, pseudo-stereo, or mono, depending on the robustness of the transmission you're looking for, the quality of the audio program content. Something called SBR, and we'll get to that in just a second. The SBR allows better utilization, more efficient utilization of the existing bandwidth. So really flexible on data rates and quality and robustness of each station in the multiplex. Again, a little bit about spectral SBR, spectral band replication. This is a big feature of the AAC Plus codec. It allows them to basically, it never fails. I get a phone call during a presentation, never fails. What SBR allows you to do is roll off those high frequencies. The higher the frequency, the more bandwidth is required to send it, to transmit it. They roll off frequencies above 7,000 hertz and simulate that. They're able to recreate that at the receiver end by sending very small amounts of data. It saves a lot of data in the transmission path. SBR doesn't have a serious audio impact on the transmission. In listening tests, it was found to be just about as good as the original content, and it's used in HD radio. They use SBR as well because they're using basically the AAC Plus codec. So this has become a real popular way of saving bandwidth and being able to transmit pretty high quality audio in very small bandwidths. When we get down to the actual modulation of DAB and DAB+, it's COFDM, coded orthogonal frequency division multiplex. Just kind of a look at it there. It occupies 1.536 kilohertz of bandwidth between the subcarriers. Each of those subcarriers are modulated QPSK, which means they have 4 different phase positions as you go around the clock, while the amplitude is constant. And so each QPSK carrier can transport 2 bits. Those bits are all combined together, and by putting them together in the same COFDM package, you've got multiple carriers. They separate them appropriately to, oh, thank you. They separate them to cut down on the intermodulation products. And what you finally end up with is a multi-carrier waveform, 1,536 carriers in that waveform, 1 kilohertz each for 1.535 megahertz, which is given a 1.712 kilohertz allocation of spectrum in the band. This is typically a band 3. The intermodulation products are generally handled, which you see there, the higher shoulders off the sides are typically handled by a post filter to bring those down, to get them down to 60 dB. Multiple of these COFDM packages, waveforms, can be transmitted as a single data stream and then separated off to their individual transmitters. It's just kind of a look at how the data stream breaks down into multiple waveforms, COFDM modulation waveforms. And then finally, each of those are put into a channel. This is, again, the existing channels, either in band 3 or in L band. In band 3, there are 41 channels available in most places, from 174 to 240 megahertz. And there are 23 channels in the L band, 1.452 to 1.492 megahertz. I'm sorry, gigahertz. So that's how they lay out into the channels. And then you have multiple modes that the system can run in. DAB mode 1 is typically used for band 3. All of the DAB plus today is using mode 1. Mode 2 and 4 are for the L band transmissions. So they have varying numbers of subcarriers, guard intervals, varying amounts of robustness. In band 2 and 4, again, that's for L band, and then band 3 was reserved for satellite transmission and is not used today. So again, it's about speed, capacity, and robustness. So that's the basic layout of the system and how the pieces go together. Let's talk about a little bit about what we do at GatesAir, some of our solutions. First of all, we're in the middle of some fairly significant competition across the industry, but we're the only supplier of all of the digital radio, over-the-air digital radio modulation standards. We do DAB plus DAB, we do HD radio, DRM, and China digital radio. None of the other competitors do this. You can see the field's pretty broad. In DAB, you've got Electronica, you've got CTE, Electrosys, NEC, Plish, Rohde & Schwartz, and Screen are all in the, and there's a lot of other little players too, right, Martin? A lot of little players in this game. Nautel jumped in to television, a couple of years ago, but they still haven't ventured into the DAB plus market, although I would assume that they could. So that's a little look at the competition. We've got a lot of products in the DAB and DMB spaces, and again, we support all of those radio modulations. Our product offerings mainly in the transmission space. We've got the Maxiva line of products. We've got the VAX 3D. We've got VLX, a liquid-cooled offering. All of these are band 3 and L band. There's the VAX Compact, which is low power, and the Ultra Compact, which is one of our newer offerings, along with the Ultra Compact Multi Compact, allows for L band and band 3 as well. So that's our transmission products in the space. They're well received in the industry. And of course, the new Maxiva XTE, which is in process now. We've got television standards defined for it, and working, and the DAB standards are coming along soon, very soon, for DAB. Right now we have the Maxeva VAX with PowerSmart from 150 watts all the way up to 10 kilowatts. Flexible, very configurable, well received in the market. Quite a lot of DAB today being done on VAX systems. And then, of course, the new XTM, yeah. Ooh. It's more processor power, it's smaller, improved pre-correction, better crest factor reduction, better performance, lower cost than our current UEP, and delivery for DAB is expected in December of this year. So we're really looking forward to that, as are our customers. And this will be integrated into the VAX 3D. One of the big draws of our system right now is our work around the EDI stream interface. I talked about that a few minutes ago. We've addressed the IP connectivity by creating the EDI interface. It's a dual stream interface that allows switching between two EDI streams for redundancy and backup. It is that IP-based transport system that broadcasters are looking for today. It's lower delivery costs and more flexibility, more reliability. These can also be linked into its generic EDI, so it can be linked into third-party head-in systems and multiplexers to help roll out DAB. We work with some of the best in the business as far as the head-end and multiplexing gear. We don't build any of this, at least not yet, but we partner with Digidea, Fraunhofer, Factum, and a few others for our DAB encoders, the Ensemble multiplexers, the routers, and all the other network infrastructure products that interface to our transmission systems. A few big successes of ours, of course, Norway. Norkring is installing several hundred of our transmitters. Maxeva VAX DAB transmitters between 50 watts and 600 watts for NRK. With the first two deployment phases done, Harris is going up. Harris, I didn't update the slide, did I? Sorry. So GatesAir is going to supply Platinum VAX HF transmitters with the PowerSmart architecture, and they intend to cease their FM operations in 2017 with 99% of the populations covered, as we talked about before. So this is a pair of 5 kilowatt VAX 3D transmitter, DAB transmitters in Oslo that are on the air and working. Number of them, there's quite a few of them already on and more coming all the time. Thought this was an interesting one. This is DAB trial in Abu Dhabi, and a very nice quote from Johnny Marone, our Middle East sales director. Got an article in one of the trades where he talks about DAB and the future of it, and basically the Middle East is very excited about DAB right now. So there's going to be, we think there's going to be great opportunity for this technology throughout the Middle East. It's just got a lot of advantages, and as broadcasters decide to transition away from analog, we're in a very, very good position to meet their needs. So that's it. Thank you all very much. Questions? Who's looking at Quincy?
They're all, they've got a mic.
Okay. Yeah, any questions? Yeah. Joe.
T2 put in a 1.7 megahertz mode, I believe, with the intent because of its later generation air correction coding and so forth to get even more services into it.
By squeezing that little bit more.
There's one vocal person I've talked to at IBCs that wants this to go. Do you see any real market movement in that direction or essentially replace DAB with 1.7 megahertz T2 for essentially just more service.
I don't know. I haven't thought about it. Rich, maybe you got some, or Ray. I hadn't really heard of it.
Okay.
I think the horse is pretty out of the barn at this point, and it's going to be hard to get people to go back and change it. Now, T2 is where that's used in Korea, right? Where else are they using it?
Well, as far as I know, the 1.7 megahertz mode isn't used anywhere.
Anywhere.
Except at this fella in Denmark's trial.
Okay.
And he's trying to be an evangelist to switch the market over because he can have so many more services, et cetera, et cetera. I just didn't know if it was gaining any traction or not. Because I hadn't heard anything outside of,
This guy.
Kenneth Wenzel, yeah. So.
Okay. Well, I guess it's something we ought to keep an eye on. I mean, I hadn't heard anything about it. Then I tend to focus on what's going on, really going on out in the field. I would think it'd be pretty hard to transition. Again, the horse is pretty out of the barn.
Yeah, I know the whole receiver end and everything else.
Yeah.
I just wondered if anybody was really doing anything.
And that would be for band 3.
Mm-hmm.
Yeah. Questions? Other questions? Yes, Courtney.
What about the United States?
The United States adopted HD radio as its digital format. Again, that horse is pretty well out of the barn at this point. We're seeing some renewed movement in HD radio here in the US. There is no mandated analog turn-off. There's no rush to turn off analog service. Basically, we Americans are pretty happy with our analog FM and not in any rush to go digital. I think consumers don't necessarily see the big advantage to it. We don't have the spectrum to allocate to this kind of DAB service. That spectrum is gone, and there's no getting that back. The telecoms, your cellular providers, the Verizons and the AT&Ts are snatching that up as fast as they can get it. That's prime real estate for them. That's part of the whole incentive auction. Now those channels, the band 3 channels, have already been they've already been reallocated. So, and they did not want to give that spectrum up for radio broadcast. We don't have any options here. So the ultimate option is turning off analog and going all digital in the existing FM band, which is what HD radio was designed ultimately to do, was to eventually cause a gradual transition to digital. Then once enough adoption was in, turn off the analog and fill in that where the analog was, fill that in with even more digital capacity. It's a good plan. It's just going to take a very long time. I'll probably be retired before we see that happen. But who knows? AM's going through the same kind of thing right now. With AM improvement, maybe the best AM improvement there could be would be to turn off analog AM and just go all digital. But there's pros and cons to that too. We're in a different situation, and other countries are too. There are other countries in exactly the same position we're in. Yes, sir, Tim.
I liked your slide showing all the competitors and who's doing what. In fact, that we're the only ones doing all 4. Are we in a position or looking at any acquisitions to glean out that space and not make it so crowded?
Way above my pay grade. Way above it. Yeah, I know of nothing. No, and we're well positioned technically. I mean, we've really got a very good technical position in this space.
So we wouldn't want to acquire.
I don't, way above my pay grade. Yeah, I mean, we are partnering with some folks around some technology for sure. Other questions? How about Quincy? Questions? Well, I see my time is just about up. I have thoroughly enjoyed it. You guys have a great engineering week this week. I'll be around, and I hope I'll be around. Thank you very much. Thank you. Y'all have a great time.